Hello, welcome to Pre-Calculus class, week 13, chapter 11, lesson 3. In this lesson, we are going to discuss about geometric sequence. At the end of the lesson, you should be able to find the common ratio, find the nth term of a geometric sequence, and use the formula for the geometric sequence for finding the general term of the sequence. And also, you should be able to find the sum of the nth term of a geometric sequence. Now let's see the content of the lesson. So in this lesson, you are going to see what is the geometric sequence, and also you are going to practice for finding the terms of a geometric sequence, and then you are going to practice finding the general term using the general formula for the geometric sequence, and also you are going to practice the application of the geometric sequence, and finally you are going to see or you are going to practice for finding the partial sum of the geometric sequence. As usual, at the end of each solved example, you must practice the checkpoint from your textbook. Now, let's go to the definition of the geometric sequence. A sequence in which each term after the first is obtained by multiplying the preceding term by a fixed amount is called a geometric sequence. This fixed amount is non-zero constant, and we call it a common ratio. Usually, we represent the common ratio by letter R. Now, let's see example 1. In example 1, you are asked to write the term of a geometric sequence. Write the first 6 term of a geometric sequence in which the first term is 6 and the common ratio is 1 over 3. Since the sequence is geometric sequence, and as you know that in geometric sequence, each term is obtained by multiplying by a constant amount with the preceding term. Therefore, to find the second term, for example, just multiply the preceding term, which is the first term, which is 6, and the common ratio 1 over 3. So the second term will be 6 times 1 over 3, which is going to be 2. The same thing you'll do to find the third term. Multiply the second term by 1 over 3. Same thing also to find for the fourth term. Over 3 times 1 over 3, which is 2 over 9. The same thing you will do for finding the fifth and sixth term. So this is example 1. Now we'll go to example 2. Before that, example 2, we need to see the general term of a geometric sequence. The general term of a geometric sequence is obtained by a sub n, which is equal to a sub 1 times r to the power of n minus 1, where a sub 1 is the first term and r is a common ratio. So this is the general formula for finding the nth term of a geometric sequence, which is very important. Now we can go to example 2. In example 2, you are going to practice to find the nth term of a geometric sequence using the general formula. Find the eighth term of a geometric sequence whose first term is negative 4 and whose common ratio is negative 2. Here, what you are going to do to find the eighth term? Yes, you have to apply the general formula, which is given by a sub n is equal to a sub 1 times r to the power of n minus 1. Here, n is given, a1 is given, and r is also given. Therefore, just substitute the given values into the formula. So, a sub 8, which is the eighth term, will be negative 4, which is the first term, times negative 2, which is r, to the power of 8 minus 1, which is n minus 1. So finally, the eighth term will be 512. This is example 2. Now let's see the application of the geometric sequence. The table shows the population of the United States in 2000 was estimated given by the Census Bureau for 2001 through 2006. There is a data given here, and there are questions. The first one, show the population, that means the data that's given from the table, is increasing geometrically. So we have to show this is a geometric sequence. And then you are asked to write the general term for the geometric sequence modeling the population of the United States in millions n years after 1999. And finally, you are going to ask it to project the USA population in millions for the year 2009. In order to show whether the given sequence is a geometric or not, what you need to do that, you need to consider the sequence which are given, values of the sequence each year. So you need to consider, like for example, the first term to be 281.4, the second term 284.5, and so on. Then let's check whether this is a geometric sequence or not. To check, we need to find the ratio of each consecutive terms. For example, the ratio of the second to the first will be approximately 1.011, and the ratio of the third term to the second term will also be approximately 1.011, and so on. So this means that this is a geometric sequence. Why? Because there is a common ratio in the sequence. That means to find the population, the number of population in any year, you just multiply by 1.011 by the year before it. So this sequence is a geometric sequence. And B, we are asked to find the general term. So to find the general term for the sequence, you have to use the general formula. So here we have the first term and we have the common ratio. Therefore, we just plug the first term and the common ratio into the general formula. So A sub 1 is equal to 281.4 times 1.011 to the power of n minus 1 will be the general term of the sequence. Finally, you are asked to project the US population in millions for the year 2009. Here what you have to do first, you have to find the number of years after the year 1999. So the number of years after 99 will be the difference between the year 2009 and the year 1999, which is 10. Therefore, the value of n will be 10. Then plug n is equal to plug 10 into the general formula that you find in B. So the approximate number of population for the year 2009 will be 310.5 millions. So this is the application of the geometric sequence in our real life situation. Then now the next thing that we need to see is going to be the sum of the first n terms of a geometric sequence. To find the sum of the first n term of a geometric sequence, or to find the partial sum of a geometric sequence, you are going to use the formula S sub n is equal to S sub 1 times 1 minus r to the power of n over 1 minus r, where r cannot be 1, where a sub 1 is the first term and r is the common ratio. Now, using this formula, let's practice example 4. Example 4, you are going to practice for finding the partial sum of the geometric sequence. Find the sum of the first 18 terms of a geometric sequence given by the first term 2, the second term -8, the third term 32, and so on. Here we have the first term and other terms. So in order to find the sum of the 18th term, you need to know the first term and the common ratio. and the number of terms is given. So we need to find the common ratio by taking the ratio of the consecutive terms of the geometric sequence. You can take any terms, like for example, you can take the ratio of the second term to the first, or the ratio of the third term to the second, and so on. So the common ratio will be -4. N is given because in the question it says find the sum of the first 18 terms. And the first term is given, which is 2. So the sum of the 18 terms will be a sub 1 will be 2 times 1 times minus 1 into -4 to the power of 18 over 1 minus 4, which is going to be 1 plus 4. So you are going to get approximately the sum -27,487,790,694. So this is example 4. Now let's go to example 5. In example 5, you are going to evaluate the sum of a geometric sequence where a summation notation is given. So find the following sum. Here, the index is I and the lower limit is 1 and the upper limit is 10, and the sequence is given by 6 times 2 to the power of I. The sequence is given. So in order to find this sum, first we need to write out a few terms of the given sequence. So when we write out, we'll get 12 plus 24 plus 48 plus, and the last term will be 6 times to the power of 10. So as you can see, this sequence is a geometric sequence because each term is obtained by multiplying by 2. And the number of terms is 10. Therefore, we have the first term, which is 12, and we have common ratio, and we have the value of n. So simply we just apply the formula for finding the sum of the nth term of a sequence. Then finally you'll get 12,276. So this is example 5. The remaining examples we are going to discuss on the live discussion. So for this video we just only saw examples 1 through example 5. So I hope you understand the lesson well. If you have any question, you can ask me during our live discussion. And thank you and goodbye.